Hello everyone, how are you all? I hope all of you are doing absolutely well. So, this video is for grade 10. In this video, we will deal with the chapter acid, bases, and salt, and it is the third lecture of this chapter. Okay, so in this video, we will deal with the topic base. As we all know, this chapter is divided into four major topics. First one is indicator, second one is acid, third one is base, and fourth one is salt. So in today's video, we will cover the topic base, and in our next video, we will cover the topic salt, and chapter will get over. So whole chapter is divided into four major topic, and you will get the four separate videos of each topic. So let's start today's topic. So student, first of all, you need to know that what is a base. So base is a chemical substance which dissociate in dissolving in water to give OH minus ion. OH minus ion are also known as hydroxide ion. So base will dissociate in their aqueous solution to give hydroxide ion. As like acid were giving H plus ion, as like that base were giving OH minus ion. So it's a proper definition of base, that a base is a substance which dissociate on dissolving water to give hydroxide ion. Hydroxide ion means OH minus ion. And bases are those chemical substance which has bitter taste. This is a property, not definition. The first point is definition, the second point is property. A base is a chemical substance which can neutralize an acid. As you all know, when an acid and base comes in contact, they give neutralization reaction and we get a salt as product and water. Okay, base turns red litmus to blue, as like acid turns blue litmus to red, just opposite, bases turns red litmus to blue. And what are alkali? What is the difference between a base and alkali? So all the water soluble bases are known as alkali. Those bases which are soluble in water are known as alkali. The example, sodium hydroxide, magnesium hydroxide, potassium hydroxide, these are the example of alkali. Means these bases are water soluble. And the example of insoluble bases are copper hydroxide and calcium hydroxide. So we can give a conclusion that all alkalis are bases, but not all bases are alkali. Okay, alkali stand for water soluble base. So as like all acid have H plus ion in common, so as like that bases have OH minus ion common in their dissociation. Like we have taken some example, when KOH is dissolved in water, what we will get? We will get K plus ion and OH minus ion. What is OH minus ion? OH minus ion is hydroxyl ion. Similarly, when NaOH, that is sodium hydroxide, is dissolved in water, we get Na plus OH minus. Here also we are getting OH minus, that is hydroxide ion. When magnesium hydroxide is mixed with water, so it will give 2 moles of OH minus. Similarly, calcium hydroxide when added in water, it dissociates to give 2 moles of OH minus. So we will see the same in aluminum hydroxide. See, the number of moles of hydroxide ion is directly proportional to the valency of metal. Here it is 3 plus, so we are getting 3 moles. Here it is 2 plus, so we are getting 2 moles of OH minus. It is all of due to the valency, as you all know. And here at last we have taken the example of ammonium hydroxide. When it dissolves in water, it gives NH4 plus, that is ammonium ion, and hydroxide ion. So we came to the conclusion that all bases have OH minus ion common. You know, we can see that on their dissociation in water, they give hydroxide ion. Okay, so OH minus ions are produced on the dissociation of every base. So hydroxide ion is common in all bases. So you need to know what is common in all bases. That is hydroxide ion. So, on the basis of their dissociation in water and ionization in water, bases are classified as strong bases and weak bases. So, a base which completely ionize in water means they will dissociate completely and they will dissociate to produce a large amount of hydroxide ion are called strong base. Their example is NaOH, KOH, LiOH. Okay, all the hydroxide of group 1 element. What is group 1 element? They are known as alkali metal. Lithium, sodium, potassium, rubidium, cesium, francium, they are known as alkali metal. And their hydroxides are considered as strong base. Why? Because they completely ionize in water and produce a large amount of hydroxide ion. And what is a weak base? Weak base is not completely ionized, it is partially ionized. And they will produce OH minus, but not as that much as strong bases do. So what are the example of weak bases? The example of weak bases are ammonium hydroxide, calcium hydroxide, magnesium hydroxide. So on the basis of degree of ionization or the amount of production of hydroxide ion, we can classify a base as strong base and weak base. So now moving forward and coming to the next slide, we need to learn some property of base. As we did the same for the acid, we have learned some properties of acid. So here we will learn some property of base. So the first property is bases have bitter taste and bases feel soapy to touch. These are some properties that bases have bitter taste. Bases feel soapy to touch. When you will touch the base, you will get a soapy appearance and at your hands, and you will feel a soapy touch. And bases turns red litmus to blue. So bases are also electrolyte. Their solution conduct electricity. Their solution conduct electricity. So bases are also electrolyte as like acid. Acid were also electrolyte and bases are also electrolyte. And as like acid, not every base and every metal reacts, but some metal react with base to form salt and hydrogen gas. Like here, in this example, sodium hydroxide reacting with zinc to form sodium zincate. This reaction is very important. It is frequently asked in your CBSE examination. So when sodium hydroxide reacts with zinc, it forms sodium zincate. And when sodium hydroxide reacts with aluminum, it forms sodium aluminate. Kindly learn the formula of sodium zincate and sodium aluminate. These are the commonly asked question by CBSE, and it also liberates hydrogen gas. Similarly, as like acid, acid reacts with metal, it will forms a salt and hydrogen gas. Here also base react with some metal to form salt and hydrogen gas. Okay, this point is very important. You need to learn. Bases react with acid to form salt and water. This reaction is called neutralization reaction. As I have written also, neutralization reaction. What is neutralization reaction? When an acid and a base, let us take an example here. Sodium hydroxide is a base and HCl is an acid. So we are getting a salt as a product and water. So when acid reacts with base, it forms salt and water. It's a neutralization reaction. Coming to the second example of neutralization reaction, here potassium hydroxide react with sulfuric acid to give potassium sulfate and water. Okay, so here KOH will dissociate to give K plus plus 2H minus ion, and sulfuric acid will dissociate into 2H plus plus SO4 2 minus ion. So it's a kind of double displacement reaction. Ion will mutually exchange. K plus will go with the sulfate ion. So it will form sodium sulfate K2SO4. Okay, and H plus and OH minus ion will combine together to get water. So which kind of reaction it is? It is an example of double displacement reaction. So always remember that neutralization reaction are the example of double displacement reaction. So coming to the next property, when a base react with a non-metal oxide, it gives salt and water. So as we learned earlier in neutralization reaction, when base react with an acid, it forms salt and water. And here we are learning that when a base react with non-metal oxide, it is also giving the same product, salt and water. So we can come to a conclusion that non-metal oxides are acidic in nature. Non-metal oxides are acidic in nature. When sodium hydroxide react with carbon dioxide, it forms sodium carbonate, which is salt, and water. Similarly, what happens when potassium hydroxide reacted with sulfur dioxide? It forms potassium sulfide, that is K2SO3. When calcium hydroxide reacted with carbon dioxide, it forms calcium carbonate. It is all salt and water. So we can get a conclusion that non-metallic oxides are acidic in nature. And we have also derived a conclusion earlier that metallic oxides are basic in nature, as well as we come to the point that non-metal oxides are acidic in nature. So remember this point, it is also a very important point. So coming to the next property, that pH of a base is more than 7. As we learned earlier that less than 7 pH is for the acidic substance. So when pH is more than 7, it means that the substance is basic, and 7 pH denotes the neutral substance. The more basic is a solution is when higher will be its pH. Means when the pH will be higher, the base will be more stronger. Okay. So when we come to the base with pH 8, 9, 10, it is considered as a weak base. And with a pH 11, 12, 13 and 14, it is considered as strong base. Okay. Some example of weak bases are NH4OH, ammonium hydroxide. Some example of strong bases is sodium hydroxide and potassium hydroxide, as we discussed earlier. And pH is a concentration dependent term. See here we have taken two samples of sodium hydroxide, sample A and sample B. When the concentration is zero point 0.1 normal, it is showing pH of 30. When the concentration is 1 normal, it is showing the pH 40. And when the concentration is 0.01 normal. Okay. As the concentration changes, pH also changes. So concentration is a factor for determining pH. So pH is a concentration dependent term. Okay. So here we are getting three values of pH for a same chemical, that is sodium hydroxide. So I guess all of you are getting my point that pH is a concentration dependent term. pH of solution will change if the concentration of solution will change. So now we will discuss some uses of bases in our day-to-day life. Okay, whenever you are facing with acidity, okay, or indigestion, milk of magnesia is a very famous base. That formula is magnesium hydroxide. It is used to cure indigestion and acidity. Okay, sodium hydroxide, that is NaOH, is used in the manufacture of soap, paper, synthetic fibers. So sodium hydroxide is a very important base. It is used in the manufacture of soap. Saponification reaction you will learn in your chapter 4. Okay, in the paper industries and the synthetic fiber, in the manufacturing of synthetic fiber like nylon, we use sodium hydroxide solution. Sodium carbonate is also known as washing soda, and sodium bicarbonate or sodium hydrogen carbonate. What is the formula of sodium carbonate? It is Na2CO3. And what's the formula for sodium hydrogen carbonate? It is NaHCO3. Don't be confused. Okay. So sodium carbonate is used as washing soda, and sodium bicarbonate or hydrogen carbonate, it's a same compound which is used as baking soda. Calcium hydroxide is used in the manufacture of bleaching powder. It is also used for the treating acidity of soil. These are some common uses of bases in our day-to-day life which you need to learn. So that's all for today. We have completed the topic base. In our next video, we will start with the topic salts, and that will be the last topic. If you have not watched the video of indicators and acid, go and watch from the playlist, and I will also share the link in the description box. So if you like the video, please like, comment, share and subscribe with your friends. Those who are in grade 10, share the video as much as you can. Okay, thank you very much. All the very best. Bye bye. Take care.